Alright, let's get into the main idea here, which is finding the equation of a tangent line to a curve at a point. Let's make that a little less abstract by providing a picture. This is the kind of thing that's going on. There's some curve, some function wiggling around, and some point P, an x value and a y value, is selected. And the question becomes, hey, what is the equation of that tangent line? All right. Hint, it's a line, right? And to find the equation of a line, all we need is the slope and a point, right? Point-slope form will give us the equation of a line. Well, remember, they gave us this point P. They gave us this point P, which is, an x and a y. I'll use a little subscript 0. That's usually what they do in the calculus book to remind you those are constant values of x and y. Those are not variables. So we have a point on a curve, and we want the equation of the tangent line at that point. So we've got the point part of the equation of a line. We need the slope part of the equation of the line. And that's why they ask for the slope of the curve at the given point P, right? Once you have the slope, you know the point P, you can create the equation of the line. But here's the issue, right? The slope of the tangent line is the definition of the derivative. Definition of the derivative. Now, technically, you're in section 2.1, so you don't know any of the shortcuts to figure out derivatives by equation, right? We're going to ignore that. On the exam, you never have to build a derivative by using the delta x goes to 0 algebra. You have to understand that perhaps, I'll maybe try this in yellow, perhaps this tangent line was created by doing approximations, right? By doing the average rate of change. Maybe here, and then the average rate of change maybe here, and then moving that yellow dot closer and closer so that we have a lot of lines from the left and right finally converging and becoming the tangent line. That's the visual idea. These secant lines that cut through the graph twice become the tangent line. But we are allowed to simplify because we are further along in calculus. All we need to do is, let's find the derivative. So we rewrite 3 over x as a power of x, so we can apply the power rule. So that becomes 3 times x to the power negative 1, right? That's because plain x is really x to the first. But division by x to the first is multiplication by x to the negative first. And then we just use our derivative rules. Okay. The derivative of y, let's apply the power rule. Right? The power comes down as a multiplier, negative 1 times the 3 and the x, but then we subtract 1 from the power. So minus 1, subtract 1 more gives us minus 2. That's equal to negative 3, x to the negative 2. And if you want to look at it in a slightly more computable way, we have that the derivative function is negative 3 over x squared. There we go. And we're given the point P, right? We are given that the x0, right, is negative 4, and the y0 is negative 3/4. So our y derivative, the slope that we want to use, is negative 3 over negative 4 squared. So the slope is going to be, let's see, that's negative 3 over 16, and that's equal to negative 3/16. Now finding the tangent line is easy because we have the slope. We know the m is negative 3 over 16, and we know that the point is negative 4 comma negative 3/4. So we just proceed to crunch out the algebra for point slope formula. Y minus the y value equals the slope times x minus the x value. I'll write the general equation over here on the side. Y minus y0 slope of the line is usually represented by m. Y minus y0 equals m times x minus x0. To remind you of the point slope formula. And the rest is kind of boring. We just crunch out the algebra. Y plus 3/4 here. And over here we'll have negative 3x over 16. And what's that come out to? Negative 12 over 16. And I guess I'm going to simplify that to be 3/4. And then over here I want to subtract 3/4 more to make it a y equals equation, minus 3/4. So looks like in the end we have y equals negative 3/16. There's the slope times the variable x, and that's minus 3/2. That's it.